we are doing this topic on forces. Can you share with me very quickly? Okay, just say into the mic, what is the topic that you are doing in school now?
I'm actually doing right now. I'm doing energy.
Energy, good.
For me, it's also forces.
Oh, okay. So one person doing forces, the rest doing energy.
Yeah.
Okay. Okay. Thank you very much. Right. So, Seika, you are doing energy also. Okay, fine. It's okay. Anyway, eventually you will cover this topic. All right. So, for the sake of those who have not done this topic, okay, I want you to look at the quick recap. So, this is about forces. So when you learn about forces, very quickly, it's just about a push or a pull, right? You already watched the video. You should be familiar as well. Okay, a force cannot be seen, okay, but the effects can be felt or seen. Okay, for example, let's say, okay, we are using a force actually to move a stationary object. Can you see the ball move? Yes, you can. If somebody pushes you, you can feel it also. So these are the effects. It can be felt or it can be seen, right? Next, you can also stop moving objects. You can change the shape of objects. You can bend it or you can even break it. Okay, so these are the effects of forces. You can change the direction of a moving object as well. Correct now? For example, a ball is moving straight ahead. Okay, if you kick it from a side, okay, from one side of it, it can actually change its direction and move leftwards. Okay. So this is what happens here. See, this person kicks the ball, right, in this direction. And then somebody interject, right? And then give it another kick from one side. So it changes the direction, it's going into the goalpost. All right, then you can change the speed of a moving object. You can make it go faster or you can make it go slower. When an object does not move, okay, looking at these two boys, right? This boy is pushing from one side and then this boy pushing from the exact opposite direction. So if let's say this object here, the box here is not moving, it means that the forces acting from the left and on the right are balanced. Okay? Okay? Energy is needed for a force to be exerted. So you're learning about energy now. Energy and forces are quite related, but many times students are confused. Students get confused on how to answer questions. We learn about 4 types of forces here. The first one, gravitational force. This is actually also known as gravity. So what is this? This is actually a pulling force exerted on objects by the earth. Okay, so it's always pulling things towards the center of the earth. Must remember this. Pulling towards the center of the earth. Gravity acts from a distance, right? Okay, it prevents objects from floating into space. So examples here, whenever you are playing balls, how come it always end up falling back to the ground? Because of the gravity pull. Okay, how come when you jump up high, you will still land on the floor? Because of gravity pull also. Okay, then how come durians fall to the ground, coconuts fall to the ground? Same thing. All right. So you also know about weight and mass. They are different things. Weight is measured in newtons. Mass is measured in grams or kilograms. So how do you define mass? All of you must know this. Mass is the amount of substance in an object. Okay. So when you are talking about your weight, usually somebody will ask you, okay, Shamu, what's your weight?
45.
45 kg, right? So actually 45 kg is not your weight. It is your mass. Clear? In scientific term, it is known as mass. If you are talking about your weight, Shamu, 45 kg, right? Your weight is actually 450 newtons. 450 newtons. To be very scientifically correct, that is your weight. your mass is 45 kg. Is that clear, Tommy? Clear? Good. So mass will not change. Okay, weight is the measure of gravitational force. On Earth is about 10 units. That's why I multiply his mass by 10, become 450 newtons. All right, mass will not change wherever you are, but weight changes. Why? If you're on the moon, Shamu, okay, you are still 45 kg in terms of mass, but your weight will be different. On the moon, your weight is actually lower. It's not 450 newtons, you know. You need to divide by 6. Because the pull of gravity on the moon is 1/6 that of the Earth. Divide by 6. Okay, so your force is lower on the moon. Your force will be stronger on Earth. It depends on how the gravity pull is. If you go on another planet, then of course you have to think of what is the gravitational force in that planet. Clear? Good. So the further the object is from the center of the Earth, the weaker the gravitational force that acts on it. Okay, so a lot of people say, okay, so if you are actually living on, you know, some flats in Singapore are very tall, right? 49 story. Okay, my sister used to stay on the 49 story. Okay, so her mass is the same. But do you know her weight is different? Okay, because the gravitational force is weaker. Okay, so on 49th floor, her force is actually lower than when she's on ground floor. Interesting, right? Yeah, but that's the way it is like. 49 story is extremely high. Okay, I don't dare to stand on her balcony. Okay, because the wind is so strong. I was so scared. I'll be blown away. Yeah. So I don't like to go to her balcony. When she opened the balcony window, you know, the wind blows like this. Very, very strong wind. So most of the time she doesn't open her balcony door. Okay. Staying on the 49th floor, but cannot open the windows, quite scary, isn't it? You don't get enough air also. So I didn't really enjoy, okay, going to her house or have her open the balcony door. Okay, I'm sure you will feel the same thing when you're there. Okay, magnetic force is the second one. So we talk about gravitational force. Second one is magnetic force. Magnetic force is actually the force exerted by a magnet. You played with a lot of magnets when you were in P4. Okay, most of you should have learned that in P4, magnets. Then you play around with magnets, right? You make magnets also, right? Okay, you make also the electromagnets. You also did the what's that? The stroking method, right? And then electromagnets is how many turns there are inside the in the coil, okay, that surrounds the nail. So these are the things that you have done. So magnetic force acts from a distance. There's repulsion. Okay, this is when the light poles are facing each other. Attraction, okay, is the pulling force. So you noted the words here. Force is pull or push, right? So repulsion is pushing. Attraction is pulling. This is when light poles faces each other, right? Or when you have a magnetic material being attracted to a magnet. Magnetic force is strongest at the poles. So in the center, is it strong? No, it's the weakest. Okay. Magnetic force cannot pass through magnetic materials like iron, cobalt, nickel, and steel, but can pass through non-magnetic material. So I was sharing with students from another class. What I did is, okay, when my children were very young, okay, I did magic in front of them. So we have a very small table. It's quite thin. Okay, so I have a very strong magnet at the bottom. And then I put the coin, Singapore coin. The new coins are magnetic, you know. Old coins are not. If you don't believe, you go and try. You ask your mom to find old coins of Singapore and then the current new coins that we are using now. You put a magnet near it. Okay, the old ones cannot attract. The new ones can. So I put a coin, okay, another country's coin that is magnetic. I put on the table on top. Then my strong magnet is at the bottom of the table. Then I start moving. So my children got scared. My own children, they think that, there's a ghost moving the coin. Okay, but it's actually me playing tricks on them. So the thin table was made of plastic. It's a non-magnetic material. Okay, magnetic force can pass through the non-magnetic material, right? That's why I can do the magic. Yeah, you can try to do that as well. If you have a very strong magnet at home, okay, you try to do this under the table, see whether it works. Okay, hopefully it does. You can go and trick those young children. You see their expression, very cute. And when you tell them your trick, they will love you so much. Okay, they will always want to play with you from then on. Okay, next. We have covered gravitational force, magnetic force. Third one is frictional force. Ever heard of friction? Okay, are you always in contact with another surface? Yes. Whether we are sitting on a chair, our butt is in contact with the chair, right? When you're standing, okay, your feet in contact with the ground, right? When you're holding a pencil or a pen, there's also, okay, contact. So if I'm holding on to my pen, okay, how come I can hold on to my pen and it doesn't drop off? Because there's friction between my fingers as well as the pen. If there's no friction, there's no way I can hold this. It will always slip off. Okay, you try to imagine, right? If you're trying to pick up something that is extremely oily, you find that it's very difficult to pick it up. Okay? You will find that it's so difficult to even try to pick it up. Okay, it slips off your fingers easily. But if that particular thing you're picking up has no oil on it, there's no oil, no lubricant, there is friction, you can pick it up easily. Yes or no? Okay? Try to think about it, especially soft things, okay, and very oily. You can't pick it up at all. Now, friction is produced when two objects rub against each other. They cannot act from a distance. They must be in contact. Okay? Friction acts in the opposite direction of motion. For example, if you are rolling a ball on the ground, right? Friction will act, okay, in the opposite direction of the movement. Like here, this girl is walking towards the front here, right? Friction will act in the opposite direction. When you are rubbing your palms against each other, if you have gone to cold countries, this is what you will do. You will see even the Korean drama, okay, even the Western movies, in the very cold condition, they will rub their hands, right? All right. Why do they do that? Because they want to produce some heat to keep their hands warm. But then friction also leads to wear and tear. See, this is new pair of shoe. This is old one. Okay, so the sole becomes worn out because of friction between the shoe and the ground. And when this happens, right, the friction between the shoe and the ground is reduced a lot. You need to buy new pair of shoe. Otherwise, if you walk in these shoes, right, and then there's water on the ground, imagine heavy rain, you can actually fall down very easily. Clear? Okay. Friction wastes energy also, because energy is needed to overcome friction in machinery as well as our daily chores. Okay. But then the useful thing is we can grip things without dropping them. I showed you the pen that I was holding. Okay. And then this person is riding a motorbike. If there's no friction between the tire and the ground, he can actually skid. He can actually die in an accident. Right? So we can walk, we can stand without falling, without slipping because of friction also. Okay. So amount of friction between two surfaces depends on how rough or how smooth the two surfaces are. This is very important because you are supposed to answer questions in the exams, okay, with regards to the surfaces. Okay, the different types of surfaces will give you different results, right? So the rougher the two surfaces, the greater the friction between them. To reduce friction, okay, we use lubricants, rollers, or wheels. Any questions so far? Okay, I'm going through this quickly because the last 3 lessons we have been on this topic. Okay, so today is just like a summary of all.
Can we just add streamlined body to